Hey there, welcome to another session on math problem solving. This is Bharat Divyang from Zugzwang Academy, and today we have a wonderful math problem. So let A be the area of a triangle with sides of length 25, 25, and 30, and B be the area of a triangle of sides with length 25, 25, and 40. What is the relationship between A and B? Take a moment, try to solve this problem. It's a very interesting problem, and we can discuss it once you've gone through the process of productive struggle. All right, welcome back. I hope you gave it a good shot. If you look at this problem without paying attention to the detail, it might be a little overwhelming. You might go in many tangents, like many of my students did, and not get the answer. But if you pay attention to it and start kind of gleaning some insights into the data, the problem actually becomes very easy, right? So first, let's imagine drawing it. Like it's always important in math to visualize it. So let's take A and let's draw this out. Okay, I mean this is a rough diagram. It's not to scale. So we know that both of these are 25. And the third side is 30. Now, when you have two sides equal, it's an isosceles triangle. And in an isosceles triangle, if you drop the altitude, then both the triangles, the small triangles, the right angle triangles that you get are congruent. Which means the third side gets bisected. So each of this would be 15. Okay, so this is what I mean by paying attention. Now, why is it that both of these triangles are congruent? So for congruency, there is a rule called RHS. So you have a right angle. Both triangles have right angles. And they have the same hypotenuse, which is 25 each. And they have a common side. You don't know the length of it, but you know it's a common side for both of them. And by RHS congruence, both of these subtriangles that you see, the right angle triangles within the isosceles triangle, they are isosceles. I mean, they are congruent. And since they're congruent, you can conclude that the third side, 30, gets bisected as 15 and 15. Now, the next step would be to actually find the height. Because if you know the height, then you know the area of this triangle. So to find the height, you think about Pythagoras theorem. You have 25, 15, and you know it's a triad of the form 3, 4, and 5. 3 times 5 is 15, 5 times 5 is 25, and therefore 4 times 5 needs to be 20. So you know this is 20. And therefore the area A can be given as half times base times height. Giving you 300. Okay, now let's apply the same logic to area B, which also happens to be an isosceles triangle of the same side length of 25 and 25. And you know, just like we proved it so far, that these two lengths are going to be equal. Together it's 40. So each of these lengths are going to be 20. And guess what? This too is a Pythagorean triad. 3, 4, 5. 5 times 5 is 25. 4 times 5 is 20. So the height needs to be 3 times 5, which is 15. So this is 15. So the area of B is going to be half times the base, which is 40, times the height, which is 15, which is nothing but 20 times 15, which is also 300. And therefore, the relationship between A and B is that A is equal to B. Okay, I hope you found this video insightful and interesting. If so, please do like, share, and subscribe. And I'll give you an additional task to do. You can prove this exact same relationship that A is equal to B also by using another formula called the Heron's formula. The Heron's formula goes this way. S into S minus A into S minus B into S minus C is the area of a triangle where A, B, and C are given, and AB plus C divided by 2 is the S value or the semi-perimeter value. By applying this, you can also see that the area of both A and B are one and the same. So in essence, to be good at math is not just knowing one method to do it, it's to know many methods and also to realize that the solution can be arrived at in multiple different ways. Thank you so much, and I'll see you in the next one. Thank you.